This video is on binomial expansion. So for binomial expansion, we need to know Pascal's triangle. So with Pascal's triangle, we have a triangle with a pattern. So the pattern goes 1, 1, 1. Then it starts with a 1, and I add 1 plus 1 and get 2, and I end with a 1. I start with a 1, I add 1 plus 2 and get 3, 2 plus 1 and get 3, and I end with a 1. I go 1, I add 1 and 3 and get 4, 3 and 3 and get 6, 3 and 1 and get 4, and I end with a 1. Again, I start with a 1, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and I end with a 1. This pattern keeps going on like that forever and ever and ever. Now, what we need to know is, based on what exponent we have, it depends which level we use. So if our exponent is a 0, and what that would look like is if I had a plus b to the 0 power, I would use 1 as my coefficient. If my exponent was 1, like a plus b to the first, I would use the second row. 2, 3, 4, 5, and it keeps going on and on. So we're going to actually put this to use in example 1. So example 1 says x minus 5 to the third power. So if I notice, my exponent is 3. So that means I need to figure out what my coefficients are going to be. So again, I build my Pascal's triangle. So 1, 1, 1, 1 and 1 is 2, 1. So this is when my exponent is 0, 1, 2. Having trouble writing 2's today. Okay, not there. I need to get my exponent to be a 3. So I do 1, 1 and 2 is 3, 2 and 1 is 3, 1. So these are going to be my coefficients for this example. So what I do is I write 1, leave some space, 3, 3, 1. And I leave space in between them because I'm going to write some things in between them. So then I take my first term, and I'm going to give it an exponent starting with a 3 because that's our highest exponent. That's what degree it's raised to. And I'm going to have them descend going from left to right. So what that looks like is I have times k to the third, times k squared, times k to the first, and then times k to the 0. So again, 3, 2, 1, 0. Then, for the second part, I take my negative 5, and I'm going to do the opposite. Okay, instead of going from left to right, I'm going to go right to left. So what that looks like is negative 5 to the third, negative 5 squared, negative 5 to the first, and negative 5 to the 0 power. So again, my exponents descended from right to left. Now from here, I'm just going to multiply everything out. So I have my groups are in black, pink, and blue. So I'm going to multiply everything out. So let's see. I have 1 times k to the third. Negative 5 to the 0 power is 1. Anything to the 0 power is 1. So when I multiply those out, I get 1 times k to the third times 1, which is just k cubed. And then I go to my second term, so I'm done with that. So I'm going to mark it off so I don't need it anymore. Here I have 3 times k squared. Negative 5 to the first power is negative 5. So 3 times k squared times negative 5, I get a negative 15k squared. Okay, moving on. I have 3 times k, and then negative 5 squared is a positive 25. So 3 times k times 25, I get a positive 75k. And again, I can mark these off because I've used them. Then I have 1. K to the 0 is 1 because anything to the 0 power is 1. And negative 5 to the third power is a negative 125. Well, 1 times a negative 125 gives me a negative 125. And this is how I can expand this binomial. You could also write it out and do k minus 5 times k minus 5 times k minus 5 and then multiply, but you would have to worry about these two first and get an answer. Once you get that answer, you would have to multiply it by that third binomial k minus 5. So the Pascal's triangle shortens the work you have to do. Moving on to my next example 2. Okay, again, I have 6m minus 8, and it's being cubed. So again, my Pascal's triangle, this is 0, 1, 2, 3. I'm looking for when my exponent is 3, so something in this line. So it goes 1, 1, 1, 2, 1, 1, 3, 3, 1. These are my winners. So I write those out. 1, 3, 3, 1. Now I start with my first term. So my first term, notice this time I have two things. I have a coefficient and a variable. So when I descend them, the 6 gets cubed and the m gets cubed. The 6 gets squared and the m gets squared. The 6 gets raised to the first, the m gets raised to the first. The 6 gets raised to the 0, the m gets raised to the 0. Then I go to my second term, the negative 8. It goes the opposite way. So negative 8 to the third, negative 8 squared, negative 8 to the first, negative 8 to the 0. So your first term goes left to right, your second term goes right to left, and they're both descending. Now I just multiply and start simplifying. So I have 1, 6 to the third is 216 times m to the third. Negative 8 to the 0 power is 1. So 1 times 216 times m cubed times 1 is a 216m cubed. So I'm done with that. I have 6 squared is 36 times m squared times a negative 8. 3 times 36 times m squared times a negative 8 is a negative 864 m squared. So I'm done with that term. And again, I'm just typing these numbers into my calculator. This one I have 6 to the first is 6. I have m to the first, or m, and then negative 8 squared is 64. So when I multiply 3 times 6 times m times 64, I get 1,152 m. Okay, I'm done with that one. Then I have 1 times 6 to the 0 is 1, m to the 0 is 1, and negative 8 to the third power is 512. 1 times 1 times 1 times 512 is a positive, it's a negative 512. I'm sorry, so it's not positive. It is a negative 512. So there you go. So you can pause this video and see if you can solve this, and then start it and watch me solve it. That way you can see if you understand it. So let's look. Now I have x to the fourth. So I've been doing x cubed, so now I need to go one level more. Okay, so I have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So now these are the coefficients I'm going to end up using. So 1, 4, 6, 4, and 1. Hopefully I left enough space. I'm not sure if I did or not. Okay, so let's see. We're going to start with our first term, x. So now it's going to start with x to the fourth. So x to the fourth, x cubed, x squared, x to the first, x to the 0. I take my second term, and I go the opposite way. So I have 2 to the fourth, 2 cubed, 2 squared, 2 to the first, and 2 to the 0. So from here, I just start multiplying. So I have 1 times x to the 4th. 2 to the 0 is 1. So when I multiply all those together, I get x to the 4th. I have 4 times x cubed. 2 to the 1st is 2. So 2 times x cubed times 2, I get 8x cubed. So I forgot to mark them out. From here, I have 6 times x squared. 2 squared is 4. So 6 times 2 squared times 4 is a positive 24x squared. Then I have, oops, can't write. 4 times x, 2 cubed is 8. 4 times 8 is 32, so I have a positive 32x. Then I have, so mark these out because I know I used them. And I have 1, x to the 0 is 1, 2 to the 4th is 16. When I multiply those together, I get 16. So this is my answer when I expand this binomial to the power of 4. Okay, I have one more example. So let's see, let me change my colors. Now we're going to the exponent of 5. So we just did 1, 4, 6, 4, 1, and that dealt with 4. So I need to go down one more level. I have 1, 5, 10, 10, 5, 1. So this one has lots of coefficients. So again, 1, 5, 10, 10, 5, 1. So again, same process. Take my first term, x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, x to the 0. Take my second term, negative 4 to the 5th, negative 4 to the 4th, negative 4 to the 3rd, negative 4 squared, negative 4 to the 1st, and then last but not least, negative 4 to the 0. Okay, so from here, let's see what we get. I have 1 times x to the 5th, negative 4 to the 0 is 1. So I get x to the 5th, so I'm done with that one. I have 5 times x to the 4th times a negative 4. So when I multiply that, I get a negative 20x to the 4th. Then I have 10 times x cubed times 16, because negative 4 squared is 16, which gives me a positive 160x cubed. I have 10 times x squared, negative 4 cubed. What is negative 4 cubed? 64? Negative 64? Don't have this one worked out. Yep, 64. Awesome. So when I multiply that together, I get a negative 640x squared. So I'm done with this one. Okay, I have 5 times x. Negative 4 to the 4th power is 256. 5 times 256 is a positive 1,280x. Okay, the next one I have, so I'm done with that. They're all starting to run together in this one. My screen isn't big enough. Next I have 1 times 1 times, it's going to be a negative to the 5th. I get 1,024. Ran out of space. When I multiply all of that together, I get a negative 1,024. And that is expand. So this is a video on binomial expansion and using the Pascals triangle.